Okay, and welcome to the third video in the vectors series. We're going to look at position vectors, quite an important concept, especially when you get on to looking at geometric problems in vectors, and the ability to use position vectors to describe situations is useful. So what is a position vector? A position vector of a point gives its position relative to the origin. So if you've got a coordinate xy, then we would write the position vector as OA, and you'd write your vector here. So OA, whenever you see that, that basically means what is the vector from the origin, what is the point from the origin written as a vector. Okay. Now if you've got the position vectors of 2 points A and B, then the vector between the two can be calculated as such: AB equals OB minus OA. So let's have a think about that. So if you've got the origin, and you've got point A, and you've got point B, yeah, and you want to find the vector A to B. Well, to find the vector A to B, you'd have to go back from A to O, which is what the minus OA is, and you then have to go from O to B, okay, if you want the vector A to B. So in general, what this is saying is if you want to go from one vector to the other, then you'd have to take an indirect route from the origin, okay? And you can apply this result to any two vectors, any two position vectors of any 2 points. So if you had BC, you do OC minus OB. It's always the second vector written as a position vector minus the first vector written as a position vector. Okay, you can do that to any set of vectors like that. Now, let's have question 1 here. Point A has this coordinate, point B has this position vector. So part A, write down the position vector of A. So O to A, the position vector would be written as minus 3, 14. Easy peasy, yep. We've got the coordinate A, and the vector, position vector of it relative to the origin would be minus 3, 14. You're then told that A to B, the magnitude of A to B is 17. Therefore find the possible values of U. Now remember, how do we find A to B? A to B you find by doing O to B minus O to A. Now O to B is U minus 1 minus O to A minus 3, 14. So an expression for the vector A to B is U minus 3, U plus 3, minus 1 minus 14, minus 15. Now remember, what was the question actually telling us? The question was telling us that the magnitude of this A to B is equal to 17, and using that we have to find U. So magnitude is there. And how do you find magnitude of vector? We do this squared plus that squared. You square both sides. $218, 9. You then take away 15 squared, that's 64. You square root 64, you get plus or minus 8, and therefore U equals minus 3 plus or minus 8, which means that U is equal to minus 3 plus 8, which is 5, or U is equal to minus 3 minus 8, which is minus 11. So those are the two possible values of U that we could have. Okay, so that's how we could use position vectors. And so the most important thing is being able to understand how to write as coordinate as a position vector relative to the origin, and how to use position vectors to find other vectors. Okay, so it's a very important skill, and those are the questions on the page, which might be well worth having a go at as soon as the video.